Have you ever found yourself puzzled by a concept in deep learning? You're not alone. Today, we're diving into the world of Keras and exploring the implementation of KL Divergence. If you've ever wondered how this loss function works, stick around because we have some valuable insights to share. I totally get it. Understanding KL Divergence can be tricky, especially when it comes to its application in Keras. Many users have faced similar confusion, and it's completely valid to seek clarity on this topic. Let's set the stage with a specific question from a user. They asked, what is the meaning of the implementation of KL Divergence in Keras? They provided a code snippet and mentioned that they can calculate KL Divergence for individual rows, but they are unsure about the aggregation process. Sound familiar? Let's break this down together. So, what exactly is KL Divergence? It's a measure of how one probability distribution diverges from a second expected probability distribution. In Keras, the KL Divergence loss function is defined to help optimize models by comparing true distributions to predicted ones. But why does Keras handle aggregation differently than other loss functions like mean absolute error or mean squared error? Let's explore that. And don't go anywhere. By the end of this video, you'll not only understand KL Divergence better, but also why Keras implements it the way it does. Trust me, you won't want to miss this. To address the user's first question, yes, the interpretation of Keras averaging the KL divergence across the rows is correct. Keras computes the KL divergence for each example and then averages these values to provide a single loss metric. Now, regarding why this is the right approach, averaging the KL divergence is appropriate because it allows the model to learn from all examples in the dataset. Each example contributes to the overall understanding of the distribution. Finally, let's discuss the implementation perspective. The reason Keras does not aggregate the KL divergence like mean absolute error or mean squared error is that KL divergence is inherently a measure of divergence between two distributions, not just a distance metric. Fun fact, KL divergence is named after Solomon Kullback and Richard Leibler, who introduced it in 1951. It's fascinating how concepts from decades ago still play a crucial role in modern machine learning. Now, let's look at the answers provided by other users. The user explains that Kullback-Leibler divergence measures the similarity between two probability distributions. In Keras, it assumes two discrete distributions and sums them up. The KL loss function can vary based on the distributions involved. For instance, a neural network might model a Gaussian distribution, and the KL divergence can be used to compare this model to a known distribution. This leads to a custom loss function that differs from Keras's built-in implementation. Additionally, in the context of variational autoencoders, the loss is summed over samples in a mini-batch and adjusted based on the dataset size. Here's a pro tip. When working with KL divergence, always consider the nature of your data. Understanding the distribution of your training samples can significantly impact your model's performance. And there you have it. You now have a clearer understanding of KL divergence in Keras. Remember, grasping these concepts is key to mastering deep learning. If you found this video helpful, don't forget to subscribe for more insights and tips.